according to the have to select a certain location for our window. So here is the maximum blade. The same location short and the back megawatts. So using this is the offshore along the Jeju Island for our you can see from here this is the window profile of the window profile for our project. Here we can see some kind of specification of our design. The power generation is 5 megawatts, and the CP, which is the implying power output, is like constant, and maybe stand for 0.4, and the equations of generator eta is 0.9. The average air density of the place is 100 meters to 300 meters, and the wind speed at 50 meters. Here is the initial phase of this is for our power output. So we hope this can be 5 megawatts. And this is the radius, the length of the blade. The initial values are equal to 120 meters. Here we can see after some kind of calculation, we got the average velocity of the wind is 10.8 meters per second, and the radius of the blade is 80 meters. Here you can see our concept along the blade. We will build our blade with 3 sections. One is the DU40L4, and another the middle part is DU30L4, and the rear part, the end part is NATA 64. Here is the computer program for our NATA 64. So some more detailed work will come next presentation. In order to reach the output power requirement, we have to taking into account of the coefficient of CL, CM, CD, and all of this can be done where some kind of some level. Here is our optimization problem. Our objective function is we want to minimize the P-real. So that means we can get the maximum power output, and the constraint is the m cube, which is the velocity of the speed of the at the tip of the blade. And especially we will minimize the R tip and the omega. And another constraint is the solidity. We also will minimize the radius of the blade. After the optimization, we can find the length of the blade, especially the diameter, the blade diameter, and we can find the best coefficient of CL and CD. And the constraint, we can see from here is subject to two parameters. One is the tip speed, and another is the solidity. And here is the profile of the chord length. We will try to find out the psi r and the beta r, and then we can get the best solution for our chord length, which is the CR. And then we will apply the BM theory to get the best solution for liquid and drag forces. And after that, we will do some airfoil analysis to find out the Young's modulus value and the weight estimation and the section shape. That's all. Any question or comment?
And I have a presentation about progress status of thing number B for intermediate design review. Our objective is power, rotor, and mooring design and analysis. And my team consists of 5 members. Actually, it's not easy to get offline communication meeting or the detailed discussion, because we have 2 foreign students and also we have 2 industry members. So it's not easy, but we have tried to do best to communicate and share ideas by email. The first one is the team mission. In order to check the stability, the stability and dynamic stability and mooring analysis, we need very much kinds of the analysis. For example, the wave and current condition analysis, and the stability analysis, and the floating body dynamics, and mooring analysis, and also the dynamic analysis. But we think that dynamic analysis can be considered in the floating body dynamics. So we have 5 analyses. So it's the number of the analyses to be needed. It's the 5. So compared to the other members, we got the top task. I think we need some extra bonus point for this term project. And the 6 software are suggested by the Professor John. And we have one member are familiar with multi-sort for the modeling analysis because we are participating in the modeling analysis for the mobile harbor project. But unfortunately, the license is expired, so we cannot use multi-sort. And also the ANSI software cannot be used because there is no license. So the shoot for software is WAMI and Rhino and Abacus and MATLAB. In the initial stage of the team project, we would like to make up the clear relationship between analysis and the given requirement. As you know that there are many kinds of original design requirements which is given in the term project phase 1. And when we started the term project 2, we got 5 additional requirements. So we would like to give some relationship between that. For example, the modeling analysis have to satisfy the 4 requirements. The first one is the structure can withstand less than 5 knots current and do not drift and withstanding 100 years hurricane and lifespan is over 50 years. So, but the design team D, the team D announced very early that Jeju Island is more competitive than the Northern Island. So, thanks to design team, especially Young-Jun, who announced this email to all of the members. So we focused on the wave condition on the Jeju Island. And there are several results will be calculated by this analysis and it's pitfall, and we have to identify the optimization problem and then feedback procedure. So we neglected this structural analysis, including fatigue analysis of float, because it needs somewhat sophisticated software to do that. So just static analysis and floating body dynamics and volume analysis and optimization. Let me say the steps for analysis. The first one. There are many kinds of vital dimensions to define this wind turbine system. For example, the height of tower and height of floater and the diameters and also draft. Maybe these dimensions can be calculated by just a simple hand calculation stability map. And then by using the WAMI software, we can calculate the exciting forces and the dynamics, forces and moments in the viewpoint of the hydrodynamics. And the second and the third, the mooring wire should endure the exciting forces and moments. So, and then we have to determine how many numbers of the wires to be needed and which diameter of the mooring wire is suitable for this success level. And also we need some fatigue analysis because this mooring wire are under continuous compression and tension. And then object optimization problem. To do the WAMI process, we need some geometry input file. It's called as a GDF file. So we have to GDF file from the Rhino software. So Rhino can export our modeling file into the GDF file. This is the initial design for the start-high wind turbine system. So this is from the final documentation from the team member D, maybe in Tom Project 1. And I'm also the one of the member of the team project D, team D. So this is the initial step. And we summarize all of the variables and the analysis to be needed and the requirements in this template. So you can see the analysis steps and many kinds of variables and requirements and values. As I mentioned before, that we need the GDF file from the Rhino 3D. So we modeled our structure in Rhino 3D software. So what we need is just the underwater structure, because one does not consider the upper part about the water plane. So we just modeled the underwater structure. You can see some part of tower and the floater. I would like to briefly explain the concept and the structure for the one-week floating body dynamics analysis. We have to include the geometry file and the wave characteristic and the mass properties. And then we can calculate the wave exciting forces and the moment from the one-week process. And this is the basic scheme of the hydrodynamics. The regular wave generates the incident and diffraction and radiation wave against this structure, as well as the structure are in 6 modes of motion. Surge wave E is the translation, and low pitch U is the rotation motion of this structure. And we assumed that the water depth is 150. But we found out that the one can deal with just regular wave. So we cannot have any result for the irregular wave. So I think it's the limitation and our obstacle to calculate the exciting forces and moment from one. So, but we cannot use the one because there is no suitable software to consider the irregular wave. And the time history for the C-state 5 can be converted to the frequency domain by the Fourier transformation. And there are 2 kinds of the wave spectrum for the C-state 5. And we can calculate the forces and moment and also the RAO value. So you can see the RAO value increases as the wave heading increases and in the lower frequency level. And these 2 figures are so similar because our concerning structure is symmetric to the XY plane. This is the RAO value for the Q motion. But we don't have any expert students for the hydrodynamics, so we need some consultation or some discussion for to verify this result. And this is the exciting forces and moment. you can see the force and the moment are maximized in the 0.3 or 0.4 frequency level in the direction of the xy. And by using these exciting forces and moment, we can calculate how much numbers of the wire to be needed and which diameter is suitable. In order to fix this floating structure in wave condition, we need some tight mooring wire to catch this floater with the sea bottom. So by web surfing, we can find many kinds of mooring wire type with respect to lifespan, but we cannot find any mooring wire to guarantee 50 years lifespan. So it means that we have to change this mooring wire after 25 years. It means high maintenance cost to change the old mooring wire. So we selected this type for 25 years lifespan. As I mentioned before, in hydrodynamics, we can calculate these forces and moment. And then we assumed that the inclined angle of this tension wire is 60 degrees with respect to the sea bottom. And then it means that the stress of the wire multiplied by the safety factor should be less than allowance stress level of the tension wire. So this concept can be formulated with this term. And also we need some fatigue analysis because this wire is under tension and compression continuously. This is the slide for the identification optimization problem. We selected optimization problem that we have to minimize the product cost, including floater and mooring wires. So we have to assume that the some variables should be fixed. So we assume that just D3 and depth D can be changed in floater design. And then this value will change the exciting forces and moment by the warming. And then we have to calculate this number of the wire and the diameter of the wire. So object function is that there are two terms in production cost. The one is the F function. F function is for the product cost for Foster. So D3 and D increases, maybe the material cost will be increased. And the construction costs are related to these two values. And also, we have to consider the product cost for the wire, including material cost and maintenance cost, because we have to change the wire after 25 years. And this is the object function for our team project 2. These are the optimization action plans until final presentation day. It remains about 10 days. At first, we have to find the relationship between D3 and D, and we have to survey the production cost function for F and G, and then we have to do the mooring analysis by using this model and stress evaluation, and we have to make up the relationship between D3 and M, or the DW is the diameter of the wire. And this is the formulation progress, and the final optimization problem can be solved by the MATLAB. So we are considering the four variables, D3, D, and D3, and the object function is the to minimize the production cost function. Yeah. Thank you for attention. Any question or comments for our progress?
Okay, I have 3 comments. First,
hello, this is Group C. Our title is Energy Conversion System Design. My team member, Jang Kyung-Kim and Kim Jae-won and me. I will start my presentation. Our presentation is divided to 4 parts. First part is production selection, and second is process design. Third is optimization. The last one is future work. Okay, it's first part, product selection. We can produce these materials from wind turbine. First, electricity is generated from wind turbine. They can be carried to land by cable. And second is hydrogen. Hydrogen can be produced by electrolysis. The process is very simple, but it has a big problem that it is too difficult to be carried on to the land. It needs high pressure and very low temperature. They consume much money. The third is methanol. We can produce methanol through synthesis with CO2 and H2. It is very useful in view of environmental, price, and transportation. It needs normal temperature and normal pressure to be carried. The last one is redox battery. We can charge electricity in battery, but it needs complex technique in the official plant to manufacture battery. This graph shows the capital cost depending on the ways of transportation. Using cable is the best way to transport energy from offshore wind turbine. This graph shows only the capital cost. When considering the operating costs together, its gap between cable and methanol will be changed. We think that the production methanol is more efficient through cost and price calculation. Next part is the process design. This process is based on Hainan process. The Hainan process originated as a method for the increasing yield of the fuel from conversion of biomass. But we changed this process to use inert gas H2 and CO2. This is detailed process design. The hydrogen is produced through electrolysis. Electrical power source is connected to two electrodes. In the water at the negatively charged cathode, reduction reaction takes place with electron from the cathode being given to form hydrogen gas. And at the positively charged anode, an oxidation reaction occurs. This process will be gather these two gases. The H2 gas will be used to synthesize methanol, and the O2 gas will be used at other parts, or it will be vented. We produce hydrogen gas through alkaline electrolysis. The method is commercialized for mass production. These features are alkaline electrolysis system for H2 generation. The H2 generation condition is like this table. And if the power generation is determined, we can determine the amount of generation H2 also. Next part is reaction. The two-stage CO2 hydrogenation reaction will be conducted to increase methanol yield. At first stage, CO2 is converted to CO and methanol. But at the first stage, CO2 conversion to methanol is so small, and so we make second stage. At the second stage, methanol was synthesized by commercial methanol synthesis. Their conditions and the last catalyst. The process has a recycle process. When the process doesn't have a recycle process, the conversion and selectivity is small. The conversion is 35% and selectivity is 12% to 12.1%. But when they have a recycle process, the conversion and selectivity is increased to 90%. This table is CO2 and H2 requirements. The gases requirements can be reduced 14.57 times from this recycle process to produce the same amount of methanol production. However, if the number of recycle is increased, the cost will be increased also. So it needs an optimal recycle ratio calculation. Next part is optimization. It is represented by Mr. Chan.
Good morning, gentlemen. I think our team the approach to further optimization program. As you see, this process is using the hydrogen and the carbon dioxide for the conversion to methanol. We make some the product optimization the model diagram. As explained, Mr. Yu, the pig gas, the pig gas means the raw material for the methanol conversion. The carbon dioxide and hydrogen can be used for the production of methanol. And then the recycle ratio is the important factor to increase the production of the methanol and the selectivity of the product. And then we also consider this is the mistake. Is not for this case is not the pure gas. Maybe the power, as you know, the power for this reactor is the transfer from the wind farm. Therefore, this term is will be changed next with the power generation cost from the wind farm. And then as you see this optimization equation for our project. The optimization program is to find the maximum benefit from the methanol. And then this equation consists of the three parts. The first part is the methanol, the cost of the methanol. Maybe this cost will be depend on the conversion factor. And the second factor is the operation cost for the process. And the last parameter is the transportation cost. And then to maximize the benefit from the methanol, it means minimize the operation cost or the transportation cost. But as you know, the transportation cost may be almost fixed for this project because the team A they determine the site. Therefore, we might think that the transportation may be the pipeline. And then the final program is to find the minimum operating cost for this program. As you know, with the chemical engineering respect, minimize the operating cost is related to the values of the parameter, such as the feed concentration ratio. As you know, this process, the feed gas is the hydrogen and the carbon dioxide. Therefore, this feed concentration ratio can impact the conversion factor. And another is the recycle ratio. The recycle ratio means it is impossible to the 100% conversion from the feed gas. Therefore, it is usual to using the residue material to the return the feed gas. It means the recycle ratio. But if we get the maximum production rate with the maximum recycle ratio, but if we increase the recycle ratio, it means we increase the operating cost. And then the next is the inlet flow rate, also the important factor to give the impact of operation cost. And then last is the labor time. Therefore, our team focus on the four parameter our team focus on to find the optimization with the four parameter value, objective function. But in addition to, as you know, the temperature and pressure and the catalyst content is also the important factor. But our study, we assume the temperature and the effect of the temperature and the pressure and the catalyst content not considered for the study. We only consider this for the parameter. This is the typical example from the previous equation model that will update in the final presentation. And then this also the another example for the optimization. If we find the optimum of the recycle ratio from the optimization program. Yeah. And then next there are many tasks for the future work, but with the focus on the determination side of the facility from the based on the optimization program. That's all my presentation. Thank you.
Questions? I will present for the first part the team number D. So first of all, I will introduce our project. The first step was to select the wind farm location. The second step is to find optimization problem, and I will present after the future work. So first of all, our team is like a fusion of different kind of behavior. So our mission is to create the economic feasibility and the system iteration of all the wind turbines. So we need to create like a function to determine the cost of our wind turbine, to design also the gearbox and rotor nacelle, and to identify the optimization problem. But a big part is also to integrate all the team together and to share some data. That's why we send some emails to communicate, to give our work presentation, and we realize also some meetings, only one, but we need to realize more after. This is an example of our meeting. Each project like show his work and what we need, and we can share information. This is a very important part of our work. Our first step was to determine the wind location, because it was very important to determine the wind speed, for instance, for different other groups, or the depth for mooring system. So our first requirement was to determine power capacity greater than 300 megawatts. So nowadays the evolution of the wind turbine generator is 5 megawatts, so we need more than 60 wind turbines. So after determining the power capacity, we should after find the configuration of our wind turbine with some rules. But which sites? So at the beginning we had to choose between two sites, source of Indian Ocean and Jeju Sea. So we had a lot of requirements, like to be safe, reliable in function of the wind speed, the depth. So our objective is to select the best site between both of them. First of all, we collect a lot of data for each. For instance, the depth, the wind speed average at 50 meters, and the cost. And we realized after a voice of customers. So we had a meeting and we realized altogether a cost after a long time. We find 8 main requirements. And with these requirements, we did an EHP. And the result of this EHP is that Jeju location is the best location. So with EHP and our data, we took a final decision. So Jeju seems to be the best location for our project. So we sent an email to all the teams to have their opinion, and the final decision is that we selected Jeju. But Jeju Island is not precise, so we need to determine the exact location of our team. So we create a database with some data, GPS coordinates, depth, distance, and wind speed for all the source of Jeju Island. So to do this one, we realized was like a mix of a wind speed map and Google Earth to determine all this data. So we had like 112 points, and to determine all these points, we had the meters. We created a grid of 3 by 3 kilometers, which represents approximately the area of our future wind farm. And also one thing is very important, the seabed in Jeju Island is very smooth, very flat, so we don't need some more precise data. And so we created, our objective is to create an objective function with this data after. So the sum of that is the optimization problem.
Hello everyone, I'm So Young Yoon is one of the members of team number 8 who can present about the optimization programs. This is one of the important things our work is so I can start. This is the Jeju Island system. Jeju Island is Google map, and this is the Korean wind map. So if you see this wind map, you can recognize this area is good for to build a wind turbine farm. So even though we choose the Jeju Island is through this AHB, but still there are lots of options to select the Jeju Island. Right here, like this. We still have lots of options. So to solve this problem, we are going to use optimization. This optimization problem is constant, so we got a constant optimization problem. This is a general problem, so we changed this function to our form. This is our objective function. Our objective function is the cost. It means is the low cost is the best size. So we have to consider about the cost, boarding cost, and transportation cost, and installation cost, and maintenance cost, and generating electricity power. It is not rate. It is outside of the cost. If you generate more electricity, the cost will be decreased. So it is minus. Our constraint is there are 3 constraints. That is more than 120 meters, because our pipe is 5 high, so it requires lots of ramps structure. So we decide this kind of things, and the distance is from the 3-5 kilometers from the ramp, because if you see the kind of wind turbine, it is not good for the people. So we decide this kind of thing, and wind blade diameter is below is 180 meters, because too long blade is not good for design. So we kind of this. And then I'm gonna show the more detail about each pattern. Yeah, this first thing is about the mooring. Mooring is cost rated with the number of mooring line and the length of the mooring line's length and the number of mooring line. The number of mooring line rated with the wind speed. If the wind speed very high, so it makes lots of waves, so it requires lots of mooring line and mooring line. And the length with rated with is the depth. If its depth is really long, it requires the very long mooring line. So we consider like this. So this is our finally we get this function about the mooring line. And then this is transportation. Actually, we have 3 or 4 options to select the transportation. First thing is using the underwater cables. Second thing is methanol, and third thing is the battery. If you input some information, the minimum thing is we think is the best. So we get the minimum factor. So if you go to the more details, if you use the underwater cable, you have to consider 2 things: CAPEX and OPEX. CAPEX is the related with initial cost, and OPEX is the operating cost. So if you use the underwater cable, if the underwater cable is related with the distance, so it's the time distance and maintenance cost. If you use the methanol, you have to consider about ship and processing facility to make methanol, and then so operating cost is the electricity, because to make a methanol it requires electricity. So it's the ship operating cost. Ship operating cost is related with the distance, so and the maintenance, and if you use battery, kind of that. Finally, you get this function about just transportation. And then third thing is the maintenance. Maintenance is also related with something. Is the first thing is distance from the harbor. If it's very far from the land, so it is hard to go to there. So its cost will be increased because operator go to there, and that is really long. The rolling line also is very long, so it requires lots of. It related with the depth. Its cost related with the depth. And then its maintenance cost is if its wind speed is real high, it is hard to go to there. So many times, so it's some limitation. So that is cost will increase. So finally, we got this function about maintenance. And this is about inspiration. Finally, we get this function. This function shows this is the inspiration. This is inspiration cost hectare, and this is the. If you want to inspiration, you have to use the crane or kind of that. That cost is related with. So we consider about that is this is a number of the wind turbine, and this is distance because it is related with distance. And then finally is the generate electricity power. So finally we got this function from this equation. You show that this function from Q number 1 presentation. And then finally you adapt the form of this function like this. It looks like very compressed, so I think we have to more simplify or kind of that. So, and then I showed one function, and we consider about another function about our wind turbines component. The wind turbine is lots of components. It's the rotor and the nacelle and generator, and it's kind of that. So we have to consider about that. So we got some equation about from some books. So we are going to use this equation to optimize our problem. So finally, the last step is our future work. Our future work is we have to solve the optimization problem. So we have lots of choice bodies. Our problem is constraint problem. So we are going to use this method. And then finally, we are going to we can use Excel or MATLAB. So we are going to use MATLAB because if we want to use the Excel, we also have to learn about that. So thank you. Are there any questions and comments?